Well, howdy y'all. It is our week on sampling and preparing you for the midterm exam. So I wanted to make sure you're familiar with some of the core things. And of course, finding the right people is critical in order to be able to say that what we have is representative of other people that are affected by that same issue. So say we're talking about immigrants. If we're just talking broadly all immigrants, then we need immigrants from every country that receives immigrants to the United States. If you want to talk about people crossing the border right now, then you need to think about what are the characteristics of the people that are crossing the border. They're not all from Mexico. Some are from Central America, some are from South America, and there's even some that are from other countries that are literally going to Mexico to cross the border and such. So finding people that represent the group you want to study and finding people that represent that group is a real challenge. And so we need to differentiate between the various levels, which we learn about populations, sampling frames, and samples. Think about what includes or excludes people from study, as well as this idea of non-probability, which means finding people that are convenient and easy to find, which is what we often do, versus probability, which is there's a random chance of being included in the study. And as long as there's a random chance of being included in the study and everyone has the equal probability of being in the study, then there's a good chance that it's representative of everybody. And really critical this week is the word generalizability. Generalizability means what we find in this study applies broadly to everyone and not just the people that we collect the data. If the people that you collect data on are unique in any way and they aren't similar to other people, at least broadly speaking, then it's not generalizable and the results only apply to the people that you collected. So let's start with this really core idea that's important for you to understand. Population is everybody, and you've heard of like the census. The census allows us to collect data on everybody, and we have a comparison then. So we know what the characteristics of the whole population is, and using U.S. Census data, we can even fine-tune it and look within various other subgroups of different ethnicities, age groups, gender, and such, and we have a sense of what if we were able to include everyone, what it would be like. Realistically, we always, when we're collecting data, we can't collect on everybody. It's too expensive. So we start off with a sampling frame. Sampling frame is the list of everybody that could be included in your study. So say we wanted to study everyone in this class and what their opinion was on a social issue. Well, you just have the emails of everyone in the class and you send them your survey. That's the sampling frame. The sample are the people that actually answer the survey. Not everyone will. So sample is less than the sampling frame. And then each individual person who answers it is referred to as an element. And this will come to pass in one of the quizzes down the road. And that element is the person. Sample is the people that answer it. Sampling frame, everyone who is eligible for your study. And population is everyone that exists that meets your study inclusion criteria. And of course, the bottom right talks about recruitment, the process by which we inform potential participants about the study and get them to participate. You could do this by mail, you could do this by email, by telephone, by in-person, someone with a clipboard outside of a grocery store. How you recruit is going to have a huge impact on whether you get people that are representative of a group or not. So depending on where you go, you might have overrepresentation of some group and underrepresentation of another. So you need to be familiar with the idea of inclusion criteria. That's what characteristics someone needs to have in order to be in the study. Usually it's someone over 18 because they're allowed to consent. And depending on the nature of the study, you might limit it to people that are of a certain gender, race, or age group. Exclusion, anything that disqualifies people. Typically, we won't include children, people that are institutionalized, people that are not cognitively capable of answering your questions, things like that. So on the left, you see non-probability. Non-probability means we're getting data that's convenient to get, but the results only apply to the people in the study. With non-probability, the advantage is we can get in-depth information from those people, very in-depth information. And it's easier and less expensive, and that's often kind of critical. We can only have so many resources. And sometimes we don't know everyone that qualifies. So say you want to study the trans population. We don't know every trans person out there. So the best way to do a study on the trans population is you go to a place where you think you might find someone, or you start with somebody you already know on some level, and you ask them to introduce you to someone else that is also trans, or you reach out to an organization that or a place where trans people go to meet each other and recruit there. That's non-probability. That's a convenience sample. And so you can get in-depth answers from the people, but you don't know whether the people you find are representative of all people that are trans, or whether or not they're different. And chances are they are different in some way, because these are people that either all know the same people or all go to the same place, and the people that are maybe more open about it versus those that are more closeted, much harder to find. So the opposite of non-probability is probability. In this case, we use a random sampling technique, just like the lottery with the bouncing ping pong balls. That's one way to randomly choose numbers. The most common way we do it is actually with a computer. Computers can generate random numbers. And so when you do that, and everyone has an equal chance of being included in the study, you end up with the people in your study being representative of everyone. Assuming you have enough people, large numbers. And there's a rule that generally you need 500 people. As long as you have 500 people in a study or more that's randomly drawn, it can be representative. And you'll note that a lot of the opinion polls and the presidential polling have between 500 and 1,000 people in them, because that's all you really need. More people in the study, the less error you're going to have in terms of representation. But 500 is generally enough. But it's more expensive to do this, because the most common way we do this is random digit dialing of phone numbers. So you start with the prefix and the first 3 digits, and then you randomly dial the last 4 digits. And that, of course, requires someone's time and effort, and it assumes that people answer the phone and willing to participate equally by gender, race, and age, and that's not always the case. Now we're going backwards back to the simple convenience sampling, non-probability, and the likelihood of being selected is based on convenience, and we don't know how representative they are. We can't generalize it. It's a great way to start, and it's a great way to collect that inductive, qualitative information. And anytime your sample size is going to be small anyways, less than 500 people, it's probably not worth doing a probability study anyways. So if you're less than 500 people, you're going to do a non-probability sample for in-depth ideographic explanations. Ideographic meaning words, in-depth words. And these are the common approaches. So convenience sampling is just using people that are easy at hand. This is typically people that are all served by one social service organization, or all go to the same grocery store, or all members of the same school. Whatever it is, they have something in common, and you just collect information from people that you can find. The next is quota sampling. With quota, you're looking at people that you're trying to get, like 5 women and 5 men, and you want to make sure that 3 of them are Hispanic and 4 of them are black and 2 are white. So you can come up with specific categorizations. Then you have representation. However, that representation, because the people that are chosen are just arbitrary, may not be totally representative, but at least you have some representation of each group. So it's better than convenience sampling sometimes if that diversity matters for the topic you're studying. But quota sampling works with smallish sample sizes, somewhere on the scale between 10 to 100. Once you get beyond that, the value of that may not be as, you might start thinking more about probability sampling. Snowball sampling means you start off with one person and they introduce you to other people that can participate in the study. And this for something that's very rare, say you're looking for people on parole or something like that, that might be one way that you can find people on parole with the assumption that they have friends and know other people that are on parole. So snowball sampling, your sample grows as you find more participants. They introduce you to more. And purposive sampling is this idea that you're purposely looking for examples to represent something. Either, like say you're studying wealth, you can find someone who's very poor and someone who's very rich. And you're looking at differences between the very poor person and the very rich person. That's the idea of maximum variation. You find 2 extremes. Political identity, you can look at the 2 extremes of political identity. Deviant case is the case of like you're looking at drug addiction. So you find drug addicts and you're specifically looking for them. That's the deviant case idea. And in a typical case, like say you're studying immigrants crossing the border and you find a few people and you call them typical cases. But it's of course an assumption that they're typical cases. The other way, probability sampling, trying to get a big group of at least 500 people. This only works when we have a list of everyone that qualifies in some way. And the most common list of everyone is the idea of phone number. The idea everyone has a phone number, though it's not exactly true, and some people have more than one phone number. But the goal is to come up with a generalizable result. So if we have at least 500 people randomly chosen, what they say should represent all people that were in the sampling frame. And so we use some kind of method, and they're listed here, but the next 4 slides describe those methods, so we're going to go through those. Simple random sampling is the idea that use a lottery ball, a random number generator to pick numbers, and the law of large numbers says that you're going to get a representative sample if you use a random method. So totally random, everyone's in a group, and in the sample, half the people are red, 6 out of the 12 are red, and in the sample, randomly selected, 2 of the 6 are red, and a quarter are green and a quarter are blue, and that's the result. It won't always work in small scale like this, but in large scale, it will work. That a random process works this way. In the real world, though, it's very rare we can do random, and so we often try some other technique that's a little simpler to do. Say you just go through a list and you pick every 3rd person on the list. That's what they did here. You see what happens, though, when you try to choose every 3rd person is it doesn't always work out. Even though it's a consistent thing and the people are in a randomish order here, it's not actually totally random. In real world, people get clustered with their friends that tend to be similar to them. And you see we no longer have this representative sample. So on your quiz, there's going to be a question about like what's the method of random selection that's the least random, and it's the systematic random sampling. So anytime it's something systematic, that's no longer random. And the representation only happens if things are truly random. As soon as something systematic is thrown in, you lose some of that randomness. So it doesn't generate a representative sample. It gives you a sample, but it's not representative. You see red is overrepresented and blue is totally not represented. That can happen. In the real world, this idea of stratified random sampling is very similar to the quota sampling, whereby you group people by a categorization that matters to you, and then you randomly choose a person within that group. And this way you have proportionate representation. By doing this, you're forcing this. And so this is one way we do to ensure we have certain minority groups included, like Native American or other populations that are in low representation or likely to be undersampled. We'll purposely divide the sampling frame by that category first, and then ensure that we get some member of each group, but a random member of each group. So stratified random sampling, sometimes used in order to ensure we include representative diversity. Cluster random sampling takes advantage of the physical identities of people. The easiest way to think about this is like a school, and the school is divided into different classes. And so if you want to get a sample of students in the class, students in the school, you could just pick specific classes. And then you could pick random people within those classes. But by randomly choosing classes first, that makes it easier. In neighborhoods, this works as well. When Census does the American Community Survey, which is a 5% sample of the whole population each year, this is what they do. They pick neighborhoods, they randomly pick houses within those neighborhoods, but that way they ensure each neighborhood has some representative in it. So that's cluster random sampling. There's always going to be some error, and that's the difference between the people we find and the actual population. The more people you have in your sample, the less error there will be, because law of large numbers suggests that as the numbers get big enough, the error tends to shrink. But there's never a perfect sample. There's always going to be some error because non-response rates are different across groups for reasons that are not totally random. So the goal is we want to generalize and be able to say that these results are true for large numbers of people. So it's important for opinion polls. We want to know what people are going to vote for president. We want to know what Americans' opinions are on major social issues. or we want to understand people's understanding of major topics. Websites like Rate My Professor, people have to actively go to in order to input that data, so it tends to be motivated by people who are at the extremes, people who really like the professor, people who really hated the professor. Something like CNN or Fox News, when they post a poll, is representative only of the viewers that go to their website, watch their news, and willing to do that. So you tend to get skewed results, biased results by the source. So getting true results is not easy. And selection bias happens when the errors in one direction and elements selected for inclusion in the study don't represent the larger population. Almost every survey, that is what happens, because people are left out. And if it's systematic, then you're going to get results that are biased in a predictable way. And even in the best cases, most of our information and understanding about human psychology is based on Western educated, industrialized, rich and democratic people. There's not good data quality from many places in the world and for many minority groups. So larger sample size, we're going to have less error. We can prove the results are meaningful. We can do more complicated statistics. That's great. But most data is actually on the smaller side because it's cheaper, and we just narrow it down. Instead of representing everyone, we're just trying to represent some subgroup of the population. Say you want to represent older adults that worked in a certain profession in a certain city in a certain time period. So you can narrow it down to a more homogeneous population that shares some characteristic, and it can still work well and get useful data. So we want to involve key community members. We want to have culturally adapted procedures, so we're ensuring we're not offending people and getting answers that truly apply to their lives. It works best when we're recruiting, whether the people that are collecting data from, that they understand how their community can benefit from the results of the research, especially if they feel that they're helping not only you, but helping their people in some way. And recognizing and accounting for cultural barriers early on, that's important and will help you get through the IRB.